Hey, hello again, everyone. Mr. Reeves here with you in the second of our two videos on operations with scientific notation. So, in the previous video, I was showing how to add and subtract with scientific notation. Remember, when adding and subtracting in scientific notation, the powers of 10 must be the same, and then you add or subtract the coefficients. All right, so the good news is multiplying and dividing with integers actually can be a little bit easier because the powers of 10 do not have to be the same. That's right, the powers of 10 do not have to be the same. Okay, so let me go ahead and pull up here my note paper. Here we go. That's what we're looking for. All right, so just a reminder again, when we have a times b to the x power, again that whole thing is called a power. X is called the exponent, right? B is called the base, and a is called the coefficient. All right, I'm just going to abbreviate because of space. So again, when we have a number in scientific notation, 4.5 times 10 to the 7th, this whole thing is a power. Okay. 10 is our base, and remember in scientific notation, our base will always be 10. 7 is the exponent, and 4.5 is the coefficient. All right? All right, so remember when we multiplied powers with the same base, we added the exponent, right? But if I have, let me do an example that's not in scientific notation. If I have 7x to the 4th times 3x to the 3rd. All right, so you guys all know that x to the 4th times the x to the 3rd part is going to be x to the 7th. But the coefficients, again, what I said this in the other video, when we did the previous problems on exponents, pretty much our coefficients were 1 most of the time. But what do I do with that 7 and the 3? Well, let me just ask you, what is 7 times 3? 7 times 3 is 21. So in a multiplication problem, you multiply the coefficients, all right? What if I had 48x to the 9th over 8x to the 3rd? Well, again, you guys know that with the powers, when you are dividing by the same with the same base, you subtract. So this would be x to the 6th. But what about the 48 and the 8? What would I do with the coefficients? I would divide and I would get 6. So I'd get 6x to the 6th. So when you have coefficients, the coefficients just do whatever the problem says to do. So in an addition problem, you add the coefficients. In a subtraction problem, you subtract the coefficients. Multiplication, multiply, division, you divide. So when I am multiplying numbers in scientific notation, I will multiply the coefficients and I will add the exponents. Okay, so in fact, let me write that down. Okay, so when multiplying numbers in scientific notation, what are we going to do? We're going to multiply the coefficients and we are going to add the exponents. All right, what are we going to do when dividing? When dividing numbers in scientific notation, what are we going to do? we're going to divide the coefficients. And we are going to subtract the exponents. Kind of silly to use line paper and then not write on the lines, huh? Okay, and then as I said in the previous video, all right, if necessary, rewrite your answer in scientific notation. Because sometimes scientific notation, I spell that right? Okay. Sometimes, in fact, very often, when you multiply or divide, you're going to get a coefficient that is not greater than or equal to 1 and less than 9. And then your answer will not be in scientific notation. And the instructions pretty much always say, write your answer in scientific notation. So the great thing about multiplying and dividing is, unlike before when we had to make those powers of 10 the same, and that was kind of tricky, we don't have to do that. Okay, we simply multiply or divide the coefficients and add or subtract the exponents, and then we are good. Okay, so you could already tell this is a much less complicated process than what we did previously. All right, so let's just go ahead actually and take a look at some multiplication and division problems. All right, here we go. Now, let me say something else regarding use of a calculator. Okay, if you've been paying attention at all, you have heard me say on multiple times, you should do as much math as possible without a calculator. It's good for your brain. It's good for keeping your skills sharp. All right. You've also heard me say that it's okay to use a calculator sometimes within the problem, but I do not want you putting the whole problem in the calculator and getting the answer from start to finish, because that is cheating. Okay? All right, so when we do a problem like this, these are multiplication problems. Remember, what the first step is going to be to multiply the coefficients, and then we're going to add the exponents. So let me tell you what part you should not use a calculator for, and I think you probably know. That would be the adding of the exponents, right? 10 to the 9th times 10 to the 12th. You should know without a calculator that 9 plus 12 is 21. So this part's going to be 10 to the 21st. This part right here, 10 to the 12th times 10 to the 6th. Again, that part right there is going to be 10 to the 18th. Okay, remember when we divide, we're going to subtract, right? So right here I have 17 minus 9. 17 minus 9 would be 8. And right here I have 21 minus 14, and that would be 7. Okay, so for those parts, you should not be using a calculator. Absolutely, positively, no calculator needed. Okay, now this part right here, should you know how to multiply 1.8 times 6.7 without a calculator? Absolutely, you should. Okay, but I really honestly don't mind if you break out a calculator at this point and you do 1.8. Let me make it so I can actually see all of the keys. 1.8 times 6.7, okay? And you get 12.06. And then for the next one, what do we have? We have 5 times 3.38. That one would go a little faster by hand because one of them is a single digit, but it's okay. 16.9. All right. And then the next one, I have 3.46 divided by 2, because now I have a division problem. So I'm going to divide the coefficients, and I get 1.73. All right, whoops. What am I doing here? This is times 10 to the 7th. What was that? All right, and then I have 8.4 divided by 4.2. 8.4 4 divided by 4.2. This one we really should have done without a calculator because it is simply 2 or 2.0. Okay? All right, so when we take a look at these, if we go back to our notes, when multiplying numbers in scientific notation, multiply the coefficients and add the exponents. We did that. When dividing numbers in scientific notation, divide the coefficients, subtract the exponents. We did that. But here's this third step. If necessary, rewrite your answer in scientific notation. Okay, well, if we take a look at these, we're good on this one, right? 2 is between 1 and 9, between 1 and 10, excuse me. All right. So this one is in scientific notation. This one also is in scientific notation. 1.73, right, is greater than or equal to 1, but less than 10. All right. But these are not in scientific notation. So I need to change 12.06 to a number that is between 1 and 10. Can include 1, as you know. So I'm going to make it 1.206, right? All right, but what did I just do to that number? I just moved the decimal that way, and I made that 10 times smaller, right? So what happens to this one? It must get 10 times bigger. All right, so this is going to become 10 to the 22nd power. All right, this one right here, same thing. It's 16.9. I need to change it to 1.69. So I just made this number 10 times smaller. So this one must get 10 times bigger. So it is 10 to the 19th. All right, does that make sense to you? I hope that makes sense to you. Okay, so again, in a multiplication and division problem, all right, multiply the coefficients, add the exponents for multiplication, divide the coefficients, subtract the exponents for division. All right, and that is all we have for this video. I'm going to make one more video doing some word problems, but not in this video. All right, thanks for watching. Till next time.